let's go back and let's look at what it means to actually write a function rule for a table. Remember that a function rule means that for any x, I can only have one y. So I'm going to look at a function rule. I'm going to look at a table, and we're going to figure out how to write a rule for this table. Remember that these variables are my independent variables, and these are my dependent because they are some function of my x. So I need to figure out what kind of function these are. Is this a situation where it's x plus something, x minus something, x times some number, or x divided by some number? What is the function going on here? Well, in order to figure out what kind of function I have, I need to ask this simple question. What can I do to 1 to get to 5? And I'm using 1 and 5 because that's 0.1 and 0.2. So how do I go from 1 to 5? Well, in order to go from 1 to 5, I have to add 4 to 1, right? 5 minus 1 is 4. So we're going to write this in and we're going to test this. Let's see if it holds true. So to get from 1 to 5, I have to add 4. What about to get from 2 to 6? What do I have to do? Well, I have to add 4. What about to get from 3 to 7? I have to add 4. The trend here is that I have to add 4 to my x in order to get my y, which means this is a scenario where my function of x equals x plus 4. So let's test this. Well, my first f of x is 5. So if I plug that in, 5 equals my x, my 1, plus 4. Is that true? Oh, but it is. Let's not stop there. You never want to stop at just one point. Let's check it with another. My second y value is 6 equals 2 plus 4. Is that true? Oh, but it is. So ultimately, this is telling me that this function is the rule for this table. Let's look at another way I could have solved this. The second way I can solve this is by graphing. So let's consider graphing this and see if I graph these as x and y coordinates, what would I get? So if I end up graphing these, I'm going to look at this first one. This is the coordinate 1, 5, or x is 1 down here, and y is 5, all the way up. All right, so this is my first coordinate. The second one is x is 2 down here, all the way up to y is 6. That's going to be here. And then my third and y is 7, which is kind of off the charts. That's about up here. So just looking at these 3 points, what could I write as my equation? Well, if y equals mx plus b, where does my y end up intersecting the y-axis? Well, hopefully it's at 0 and 4. Okay, so my b is going to be 4. And what is my slope? Well, if I'm looking at my slope is going to be rise over run, right? So my rise is 1 and 1. So that simply tells me if I'm going up by 1 and over by 1, that it's my actual equation is y equals 1x plus 4. Or simply y equals, y equals, I'm doing this with a baby. Okay, y equals x plus 4. Now, remember that that is about the same as what we got before. All right, what if I have a table that looks like this? Again, you need to ask yourself, what can I do to fill in the blank with an x value, to get, fill in the blank with a y column. So, for example, what can I do to 1 to get 1? Oh gosh, I don't know. Plus 0? Well, let's see. What can I do to 3 to get 9? Well, here I got to multiply by 3. What can I do to 6 to get 36? I'm going to multiply by 6. Well, what can I do to 9 to get to 81? Well, I multiply by 9. So is it possible that I had to multiply 1 by 1 to get to 1? Ah, that makes sense. So hopefully you recognize that you are multiplying each one of these by itself, which is the same as simply squaring them. So for each one of my x values, I'm multiplying by x to get to y. So this is a situation where my function should be y equals x times x, or simply y equals x squared. Now, if you end up graphing this, you would get a situation where 1 is about 1, and 3 goes all the way up here, and 6 is even going to go like way up here. You're going to get a parabola type shape. It's not going to be linear. So keep that in mind when you graph, that anytime you have a squared situation, you get a U-shaped graph. If it's a negative x squared, it's going to be something that looks like this. All right, let's say you have a word problem. These are really helpful here. Let's say that you have a scale model that is about 20 times the size of a normal desktop computer. And this is my model. So here, I could end up writing my 20 times a normal computer is a crazy model. And then I could end up filling this in and coming up with a chart for C and M. All right, this is just an example. I'm going to upload a couple of questions for you to do tonight for homework. I hope this helped. I know it was fast. Feel free to text me with any questions or email me.